Alright, we're going to condense the logarithms. We're going to go in the opposite way than expanding, using the same properties, or same rules here, but we want to go in kind of the reverse order. So if we see numbers that are out front, like the p, we need to put it back up, and that's what I see here, right? So I'm going to put the 5 back up here, and put the 6 back up here. So I have the log base b of x to the 5th plus the log of base b of y to the 6th. Then you should be able to see that we have something that looks like this, right? They're being added together, so the addeds go back to the product, right? The sum goes to product. Alright, so that means the things in here, this and this, are in a single log, base b, and they're multiplied together. So if you want, since they're a single log and they're going to be multiplied, you can put parentheses there, x to the 5th, y to the 6th. Or without the parentheses is just fine, but make sure that it's x to the 5th, y to the 6th, and nothing's being raised to the top, right? Now if you expanded it out, remember you'd split it up, and then bring these guys down. Alright, next example. Same thing, what goes anything up to go up? Nope. Nope. Nope, nothing looks like to go up, so I just got to put things in the right spot. Positive out front, right? It says positive minus, and then that's the quotient rule. The things with a negative, see the negative out front? The n is down, right? So I should have two things that are down. So this actually has one thing in the numerator, just the 5, because that's where the m is. It's positive, right, out front. So it's positive out front, so 5 goes up. Then minus log base 3 of 10. So if I'm condensing these 3 logs to 1, the 10 has to go down. Because if you hide, like pretend this one wasn't there, right? You have basically just these two, and the 10 would go down. So the 10 has to go down. Alright, but then unfortunately we do have another term there, right? So this one also has to go down due to this negative sign out front. Again, because it's like taking another minus another n thing, and that goes down. How does the 1/2 goes down? Well, I'll just put it down here, times a half. Alright, nice that this comes out actually, right? 10 times a half, or half of 10 is 5. So let me figure that out. Well, then and remember this is the input, right? So, but we know what 5 divided by 5 is. And then, do we know the log of 1? Any base? Remember, it's asking the question, 3 raised to what power is 1? 3 raised to the 0 power, right? So the base doesn't matter. If you take the log of 1, you're going to get 0. So this is actually equal to 0. So the answer here is 0. Alright, let's look at another example. Natural logs, same thing, doesn't change anything, you keep doing the same. Positive, so I say on top, negative on the bottom, positive on top. All I gotta do is put this 2 up here, okay? So we have a natural log of x to the 6th on top, x cubed on the bottom, right, because it's negative out front, and then 4 squared, whoops, not on the bottom, right? 4 squared where? It's positive, so 4 squared on the top in the numerator, times 4 squared, like that. Alright, so this whole thing is the input. Don't get the idea that this x cubed is under the natural log. Remember, the function has an input, and so it's helpful to put some parentheses in there. It's the input of the whole thing. This fraction bar is on the input to the function. What I'm trying to say, it's not this. This is much different. See, look at that. Now the input is just these two things, and you're dividing it by x cubed. The natural log of this divided by that. So be careful when you're putting things in the denominator. That's why parentheses are definitely helpful. They should probably be used a little bit more, so you know what you're doing. So now I have this. I can reduce some things and figure that out. X to the 6th divided by x cubed, that actually reduces, right? It makes x cubed on top, and that's a 16. So this is natural log of x cubed times 16, or the natural log of 16x cubed. And parentheses probably are a good idea. Alright? Now it's that time for you to actually try some. Here are the 3 rules again. Remember, if you have numbers out front, start with this and put them back up. Right? And then condense with the other rules. So, give both of those a try, and then I'll do it in a moment, so pause it. Alright, now I'm ready to do it. Remember, the numbers that are here need to go back up. Okay, so the 2 goes up on the a, that's pretty easy, right? Log base m of a squared. Now you can either bring a negative 3 or a positive 3. I tend just to bring the positive version, so then it's minus log m. And now remember, the 3 is going to go up here, but what happens with exponents when you do that? They multiply together, b to the 6th. Now remember, the negative could have went up there, and you would have a negative 6 and a positive out front. Things would change then, and you'd have to use the other exponential rules to simplify it later. But right here, now I'll just use this property, right? Since they're being subtracted, then they should be divided. Keep in mind the parenthesis and the n down there, right? Again, like before. So this becomes log base m of a squared over b to the 6th. And I'm going to put my parentheses around so that that's the input. And then that would be the single logarithm. Alright, over here, notice the minus comes first, right? It's not exactly in that order, but remember, the one log that has the negative, the input goes on in the denominator. So it doesn't matter that it's first. Let's put up the 3/4. Let's put up the 2. So minus log base 3 of 16 to the 3/4, right? Plus log base 3 of 8 squared. Well, I have some numbers I can figure out here, right? 8 squared is pretty easy. Let's do that one first. 64. 16 to the 3/4. Well, going back to exponential rules, that means 16 cubed and then the 4th root, or the 4th root and then 16, and then with that cubed, right? So I know the 4th root of 16. Some number times itself equals 16. 4 times, that would be 2, right? So I'm just going to figure this out over here, right? So 2 to the 4th is 16. Okay, so the 4th root, like this, of 16 is 2. So that's this portion, right? Then we have to cube it. Then 2 cubed. That's 8. So this whole mass right there is 8. Minus the log base 3 of 8. Alright, now I could rewrite this another way, right? Basically this says the log of 64 base 3 minus the log of base 3, the log base 3 of 8, right? So basically, since there's a negative on this one goes in the denominator, this one goes in the numerator, and we can simplify 64 divided by 8 is 8. So this one actually simplifies all the way down to this, log base 3 of 8. Hope that helped. If you have any questions, please post in the discussion board.